All right, hello and welcome to our very first section, which is entitled An Introduction to Whole Numbers. And within this section, we are going to identify the certain objectives. So the first thing is identifying counting numbers as whole numbers. Then we're going to model whole numbers. Third, we're going to identify place value. Fourth and fifth, we're going to use place value to either name or write a whole number. And then finally, we're going to end this section with rounding whole numbers in general. So what I want to begin by is identifying, okay, well, number one, like what are numbers, and then what is this thing called a whole number? So if you think about counting, like when you were learning how to count, you always started at 1, 2, 3, and so forth. So one of the ways that we can identify counting numbers is a tally system. And we've all seen this before, where we just said, we made these little dash marks or these lines as 1, 2, 3, 4, 5, and you drew a line through it, and you would say this is 5. Okay, these are called counting numbers, and what makes counting numbers so special is the fact that counting numbers start at 1 and they just stay positive. Now, these three little dots right here just mean etc. or keep going. The technical name is ellipses, and it just means just to keep going. Okay? Now, whole numbers are just slightly different. And this is where we're really going to start our focus with this semester. So whole numbers start at the value 0. In other words, somebody had to invent this number. Because like I said, if you think about it, if you look at a child, or a relative of yours, and you're watching that child grow up and they learn how to count, using their fingers. Well, you start off at the number 1, hence we call it a counting number. So somebody along the way said, you know what? What if we don't have anything? How do we represent that? So we had to invent the number 0, and then we gave it a brand new name, which are called whole numbers. Now, throughout the entire semester, we're basically going to be doing 4 things over and over again. And those 4 things are called operations. And they are add, subtract, multiply, and divide. It's just we learn how to use these 4 operations with all different types of numbers. In chapter 1, we focus strictly on whole numbers. In chapter 3, we start talking about integers. Chapter 4, we talk about fractions. Chapter 5, we will explore decimals and so forth. So, and you're going to be doing add, subtract, multiply, and divide from now until you're basically done with math. Okay? It's just how do we manipulate different types of numbers, or that scary word, variables. And my approach to this class is I just assume that you've never seen any of this, because I don't want to assume anything. So when I introduce a new topic, it's gonna be I will treat it as if you've never seen it before. Okay? So remember, whole numbers start at the value of 0. So let me just write this one more time. Whole numbers, and I'm gonna define it using the list method, or a roster method. So we start off at 0, and then we stay positive, and we just keep going. Okay? Now, you got to remember, whole numbers look exactly like this. So, for example, 2.1 is not a whole number. Okay? And this will actually, I'm going to put a star next to this statement here, because this will help us throughout this entire first chapter. In other words, if you're doing the homework, so I'm gonna write this in a different color here, because this is kind of like one of those things you just want to remember. So if we are doing the homework, or quiz, test, whatever, and our answer is not a whole number, then we know something is wrong. All right? So every single answer that you get in chapter 1 will always be 0, 1, 2, 3, 4, 5, 6, 7, 8, and so forth. Okay? It's never going to be a fraction. It's not going to be a decimal. It's not going to be a negative number. There'll always be a whole number. So that's like a good way to kind of sit back and think to yourself, when you actually come up with an answer, does the answer make sense? Well, is it a whole number? Yes or no? If the answer to that question is yes, you are probably on the right track. So that was our first little introduction here, is identifying counting numbers and whole numbers. So now what we're going to do is we're going to transition into modeling whole numbers. So let me just write this. And we're going to model whole numbers. Now, there are tons of ways that we do this. I think the easiest way, and you're going to have to pardon my artistic ability. In fact, maybe I should be using the correct color for this. All right, is money. And like I said, you're going to have to excuse my artistic ability. I went to school for math, not for art. Therefore, my artistic abilities are very, very poor. But we can use money to model whole numbers. Okay, so like if you have a $5 bill, then that stands for a count of 5. Notice it's a positive number, therefore it's a whole number. Okay, now we could have multiple $5 bills. All right, and that would give us a total of $10. So you can add whole numbers together, okay? There are other ways that we can actually represent whole numbers as well. And what we call this the base 10 model, okay? Or base 10 blocks. So base 10 blocks. So before I go any further, I want to explain what this base 10 thing is, okay? So somewhere along the lines, and if you're really interested, all you have to do is just, contact me, send me an email, and I will give you a little write-up on when this happened. I've taught a history of math course before, so I would just have to look up this information to remember the exact time this happened. But anyways, a long time ago, different cultures had numbers, but they had different bases. Now, what we mean by that is this. When we learn how to count using whole numbers, all right, and I'm gonna do it in a column, we start off at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we start over again. Notice that I put a 0, but then I carry over a 1 into the next place value to the left. That is called base 10. So we get the base 10 model because from 0 to 9, we have a total of 10 values. Okay? And then the process just repeats. The Mayans used base 20. The Egyptians used base 60. So there's all these different bases that existed, but then there was a convergence of thought when it came to mathematics, and everybody pretty much agreed, okay, base 10 is going to be the easiest, and that's what we've settled on here. So in the base 10 block model, a block represents 1. So we just call this a block. So like I said, you're going to have to give me a second, only because I got to make sure this is correct and my artistic ability is poor. Okay, so this represents the value of 10, and this is called a rod. And then the last one we have is what we call a square. So let me go ahead and draw that for us. All right, I'm back, and here we go. And this is just called, like I said, It's called a square. And this represents the total quantity of 100. And if you think about it, if you count the number of blocks across the top row, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if we go down the first column, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no matter which way you look at it, you have 10 rods if they go in column format or row format for a grand total of 100, okay? So we can use this to our advantage because we can break down numbers very quickly. For example, let's say we wanted to look at the number 158. In the block model. Well, all you would have to do is just draw a square, 5 rods. So here, let me write it out. We would need 1 square, 5 rods, and 8 blocks. So let me show you what that looks like. All right, and here we go. So just to break this down, this is 100. The rods represent 50. And then the blocks represent 8. And if you were just to total this up, you would have the number 158. All right, so now we're going to transition. And we're going to go ahead and learn about place value. And if I were to kind of stress, what's really important in this section, it would be place value. So your book actually has a very good picture of this. So let me go ahead and I'm just going to copy and paste that picture into our notes because it's a really good picture. Okay, and here's the picture that I was talking about from your book. And this identifies all the place values that we have. So first thing across the top, we got the word place value. And the second row, reading from left to right, we have trillions, billions, millions, thousands, and ones. These are called periods. And if you notice, every 3 numbers, so if we were to look at the very bottom, I'll draw an arrow to where I'm talking about. So if we were to look at the very bottom, notice that on the far right-hand side, we have the 4, which represents the 1 position. That would be like if we had 4 blocks. Then we have a 9, which fills in the tens position. That would be the same as saying 10 rods. And then the hundreds, that would be one 10 by 10 square, and we have 1 of them. So if you follow this first period is called the ones period, okay? Because you have 1, tens, and hundreds. Then in the next one, that is called the thousands. And if you look, it starts off with the 8. So let me go ahead and I'm going to start highlighting things for us. So the 8 is in the thousands position. And then to the left, you have 10,000s and 100,000s. Now, the reason why I really wanted to break out the highlighters is because I wanted to show you that here's the word 10, here's the word 10, here's the word 100, and here's the word 100, okay? It's just the ending, because we're in the thousands period, we say 10,000s, 100,000s. Then if we keep moving to the left, we have millions, and then we have 10 millions, 100 millions, and then the next period would be billions, 10 billions, 100 billions, and so forth, okay? The only thing that this table doesn't do for us, which I kind of wish it did, so I'm going to fill it in red for us, is I wish it would just show you where the commas go, because the commas separate the periods for each other. So this number is 5,278,194. Now, reading numbers, I'm going to get very technical with that in a second, but I do want you to realize that you didn't hear me say the word and, because when we read whole numbers, there is no and. Although a lot of us would probably read this 5,278,194. Because I said that and is actually incorrect, and I'll explain why later, okay? So, like I said, please go over this place value chart, because this is going to transcend from now until we're done. especially in this section, because when we go ahead at the very end, we're going to learn about rounding, okay? And in order for us to properly round, we got to know place values, okay? So now we're going to transition into part 4. And part 4 is going to be using place value to name whole numbers. Okay, so I think I'm just going to start off with just a very basic example here. So we're going to go with this number. And we're going to write this in words. Okay, now to write a whole number in words, we have basically 2 steps. So step 1, we're going to start at the digit on the left and name the number at each period, followed by the period name. We do not include the period name for the ones. Then step 2, using the commas and the number to separate the periods. So for example, with this first number, I noticed that this 2, so I'm just going to rewrite the number here. This 2 is in the millions position. So I would start this off by saying 2 million. Okay, 2 million, comma. Now, that is going to be 98, but it's in the thousands position. So I say 98 thousand, comma, and then this is just in the ones period, but remember, we don't say the ones period. We would just say 700 18. And that's it. So if we could just follow these 2 simple steps, we can write any whole number that we want in words. All right, so we're going to try another one here using these steps. Let me just zoom out here a little bit just so we can keep those steps in front of us. So let's write that number, which I just wrote out, in words. Okay? So once again, we're going to start at the digit on the left, and we're going to name the number in each period. So this is 402. Million. Then we have the thousands, so let's go ahead, let's name that number. It's going to be 300. $81,000, comma, 2. That's it. So 400, 2 million, 381,002. Now, that word "and," like I said, some of us, and I'm going to be honest with you, if we were at the grocery store and you saw me in the grocery store and I don't know why you would come up to me and ask me to read this number in words, all right? And I said 402,381,002, I wouldn't be too nitpicky about that, all right? But technically, the word "and" in math, when naming numbers, means decimal point. So the "and" is the decimal point. Notice in our numbers, we're studying whole numbers. We do not have any decimal points at all. Okay? So it's just one of those things where if you were taking a test, okay, just write it out properly, and that's it. If you were just talking to somebody on when you're driving down the road or at the grocery store, who cares? That's the way I look at it. All right, so let's go over the next objective. I don't even know what it is. 4. Okay, wow, we're already on objective 5. This is great. So objective 5 is going to be use place value to write whole numbers. Wait. All right, so the difference here is right. Sorry, I just confused myself a little bit. All right, so in this example, or in this part of the lesson, all right, we actually have 3 steps. So let me give you those 3 steps right now. All right, and here's our 3 steps. So step 1, we want to identify the words that indicate periods. Remember, the ones period is never named. Step 2, draw 3 little blanks to indicate the number of places needed in each period. We're going to separate them by commas. And then step 3, name the number in each period and place the digits in the correct place value position. So let me show you an example of this. So we're going to write the following number in what we call standard form, which means write out the numerical value. So let me put that right there. So we're going to do 53 million. $502,000 22. Okay? All right, so let's break this down. Oh, sorry. Let me fix this real quick. My computer does that from time to time because I don't know where to tap it. So, first things first, we're going to identify the periods. From left to right, we got millions, we got 1,000, and then we know the very far right-hand side is always going to be the ones. So from here, we're just going to draw three little lines and separate them by commas. And then we're going to name each number period and place the digits in the correct place value position. So when you see the number 53, all we need are just 2 place values for that. Then we see 502, so 502, and then 22. So we put a 0 because all we need is just 22. So to make it look nice and pretty, we would just write 53,502,022. Okay? So the last thing I want to talk about is going to be rounding. Now, we do this all the time, even when you don't even think about it. For example, when you go shopping, let's see here. What could we shop? Oh, here we go. Because it's about 1 o'clock, 1:30 in the afternoon when I'm making this video, I'm thinking food. So if I go to the local deli, I really like just a regular sandwich. If I go to the regular deli and order a turkey sandwich, chips, and a drink, I can look on the board and it will say the turkey sandwich is $4.99. Chips would be $1.99, and a drink is also $1.99. So, and I know we've all done this before. We would probably look at this and go, okay, well, lunch is going to be about $6. All right, lunch would be about $6. All right, or I'm sorry, $7. Lunch would be about $7, okay? And how we got that so quickly is we rounded each one of these numbers. $4.99 is basically 5. $1.99 is 2. And another $1.99 is 2. So now when I add these up, I get $9, which I was pretty close on my guess of $7, okay? Now, as we progress throughout the semester, we're going to get way better at this, okay? So, to round, basically we have a couple steps, and what rounding does, okay? Rounding gives us an estimation of the actual value. All right, all it gives us is it gives us a guess. Okay, so to round, let me go ahead and provide you with those instructions. All right, so here we go. Here's the how-to for rounding. Okay, so step 1, you want to locate the given place value. Step 2, underline the digit to the right of the given place value. Now, step 3, we have options. We have option A, we have option B. So step 3 says determine if the digit is greater than or equal to 5. Now, what they're telling you or what they're asking you is the underlined digit. Okay? And this is from step 2. So if that number is 5 or more, then you would say yes, and you would add 1 to the given place value. If the digit is a 9, you replace it with a 1 and add 1 to the digit immediately to its left. I will show you an example of that. If your answer is no, do not change anything. All right, don't change anything. And then step 4, you're going to replace all the digits to the right of the given place value with zeros. Okay, so we're going to end this lesson just by doing just a bunch of these examples. Okay, so here we go. Let's go ahead. Let's try a couple. So we're going to round. And I'm going to just let's pick a random number here. Let's make this 5 a 4. There we go. So we're going to round 147,981. Part A. To the nearest 10. Okay? So what I would do here, as I would rewrite the number, let's write it nice and neat, and then we're just going to go ahead and we're going to follow our steps from above. Oh, sorry. So first, locate the place value that we want to round. So that place value is the nearest 10, so I draw a little arrow underneath the 8. Step 2, we're going to underline the digit to the right. Now we need to make a determination. Step 3, determine if this digit is greater than or equal to 5. Well, the answer is no. This is not greater than or equal to 5. So we do not change anything. Step 4, we replace all the digits to the right of the given place value with zeros. So directly underneath, I'm going to write 147,980. This is my rounded value. Okay, that is what I rounded. Okay? Now, let's go ahead. Let's do part B. Same number to the nearest 100. All right, so once again, I start by writing the number. Now, since I went the nearest 100, I put an arrow underneath the 9, and I underline the 8, the digit to the right. Now, step 3, let's go ahead and let's make our determination. I can see that that 8 is definitely bigger than a 5. So I'm going to add 1 to the given place value. So I know this 9 actually turns into a 10 because that would be adding 1 to it. And that's where this kicks in. If the digit is a 9, replace it with a 0 and add 1 to the digit immediately to its left. So what we're going to do is we're going to rewrite this number as 148,000 and then replace everything with zeros. And there's our rounded value right there. Okay? Let's try another one here. Let's round the number to the nearest 10,000. Okay? So our number, 147,981. So identify the place value. That's going to be right here. The 4 is the 10,000th or 10,000 place value. I underlined a 7. That is definitely larger than 5. So step 3, the answer is yes. So I increase this by 1. I don't have to worry about carrying anything over. And this also turns out to be 148,000. And that's going to be it for this lecture. So good luck this semester. If you have any questions, feel free to contact me. I make these little videos for every single section, so make sure you check them out. Enjoy your day. Have fun learning. Bye.